We will be using a product called Vernier Video Physics. Video physics is a fairly simple application that lets you capture video of an object in motion, mark its position frame by frame, and set the scale using a known distance. It also draws trajectory, position, and velocity graphs for the object. We will be using this application to experiment with and to try and improve sporting technique. There are a wide range of sporting abilities we can try this with, but for now we will be analysing the kick of a football. I've recorded a video earlier, but you can video through the application. Let's just load this and have a quick look at what we're dealing with. Now, notice on the ground there's a tape measure. We'll use that to work the scale out. Now we'll go back to the point where the football is first kicked. Plotting points. To plot our first point, take the crosshairs. You can put your finger anywhere in this outside ring here and drag it across. And we try and put the crosshairs exactly on the ball, and then we just tap the screen on the crosshairs and it sends us to the next frame. So we do this, it's a little bit time consuming, but we do this for every frame that we're interested in. In this case the football is nice and large because it's close, so it makes it quite easy to see in every frame. If you're using a small ball or it's far away, you may have a little bit of trouble spotting it, so backgrounds are important considerations when you're taking the video. Alright, I won't bore you with all the details here because this takes a little while to do. I shall now stop it and come back in a moment. We're back and I've done all the points now. As you can see, one of these points, this one over here, is a little bit out, so I'm going to show you how to correct that. But I'll show you a few of the other features first. And we have the slider down here, which makes it easy to go backwards and forwards through the video, and we can potentially stop it close to where we want it to be. That's pretty close. And then we have the forward one frame and back one frame buttons. Just press that there, you'll see it flash, and you can see that point there is actually out. So to fix that, all we have to do is with our finger we click and we just drag the crosshairs back onto the football and touch it, and that's fixed. So now we have all the points as close or very near to the centre of the football. On the ground down here you can see we've got the tape measure. I think that was 3 meters. So we'll use that to scale the video. I'll just show you how to do that. Origin and scale, you'll see just up the top here there's an origin and scale item. Push that. Yeah, there we go. It says 355 pixels. The area between these 2 points here is about 355 pixels, and that is equal to 3 meters. So we can move those 2 points around, as you just saw, and we can also set our origin, which is this section just here. It doesn't really matter where the origin is. It should be close to where I originally kicked the football, so we can pop it there. And with that, this product can now calculate and scale things appropriately. If we look in the top right hand corner, we have a graphing facility. So you can see here, I've pretty much got the scale close. I've got the scale close to the 0 on the X directions, close to where I kick the football. It really doesn't matter too much. And you can see it's not a perfect line, it's a tiny little bit out, but for our purposes it's certainly accurate enough. We have on the base, we have the displacement in the X direction, and on the Y-axis we have vertical displacement. We can go off to the next graph now, where we'll see displacement versus time in the X direction. So the first section of it, up to about 3.5 3.55 seconds, you can see that's where I'm walking along and I'm about to kick the football. After that, you can see the football has sped up considerably, and its displacement is, the rate of increasing displacement is much higher there. In the bottom graph, you can see the velocity versus time. So initially it's going quite slowly, then it accelerates sharply over the course of about 0.1, 0.2 of a second. It goes from around about 2 meters per second to about 15 meters per second. This next graph shows the y displacement versus time. That's the vertical displacement. So the first part of the graph up to the point where it's kicked, it's falling down, and then you can see it's going up again and slowing down on the way up because gravity is obviously slowing it down. The second graph shows the y velocity, the velocity in the vertical direction, which starts off as negative and then goes sharply positive up to about 7.5 meters per second and then tapers off. Okay, so that's all we have in this particular product, but we can export it to other things. We can either email it, say, to our Gmail account, or we can export the data, the raw data. I can export to this program called Graphical, which is also done by Vernier. And this graphical program gives you a little bit more flexibility in terms of what you graph. We can see both x and y displacement are on the same graph here versus time, and we also have in the bottom graph x displacement and x velocity and y velocity versus time. We can add extra graphs. There's a few functions here. It's a good program to fiddle around with and just see what you can do. That's part of the exercise, is to experiment with this and just see what sort of graphs you can draw, what sort of statistics you can get. If you see what I've just done here, I can take the x velocity off and put an x displacement versus x velocity, if that's what we inclined to do. You can also highlight areas and get statistics for those areas. These are summary statistics which probably won't be used in our particular exercise, but it's good to know they're there.